Alright, you guys, so we're going to talk about zeros when it comes to polynomials. So the points at which the function intersects the x-axis is a zero. A polynomial function of degree n can have at most n real zeros. An even degree polynomial has an even number of zeros, and an odd degree of polynomials has an odd number of zeros. So we're going to put this into our calculator. So y equals, and I'm just going to type in the equation as I see it. Oops. I hit graph. I can see there's some minimums and maximums, so let me kind of figure that out. I hit second calc. Let's do the maximum first. So that's at 1.2, so negative 1.2, 2.1. Let me find the minimum. And it's at 0.5, negative 0.6. All right, and then I'm going to find my zeros. So you hit second calc 0, and there's multiple zeros. So I'll do my first one. Is at 1, 0. Second calc 0. Is at 0, 0. And I gotta put my next 0 over here. So second calc 0. Is at negative 2, 0. So I could finish graphing. And we have a nice little curve like that. Just ignore what I did there. Identifying the zeros, so our zeros are at 1, 0, and negative 2. So again, just using the calculator, we could find all this out. I'm not going to do it again for number 2. I'm just going to jump ahead. Linear factor of a polynomial reveals its zeros. Linear factors can be found by writing the polynomial in factored form. So if I just factor, so like for here, I could take an x out, and I get x squared minus 2x minus 15. This could be factored even further. I think 3 and 5 would give us that too, so I need x minus 5, x plus 3, right? So if I set each of those equal to 0, I would know that my zeros are 0, positive 5, and negative 3. So just like before, when we factor, those are our linear factors. Multiplicity. Multiplicity of a 0 is equal to the number of times it corresponds to a linear factor to occur. So if I factor this out, I'm going to take an x out. I get x squared minus 6x plus 9. This breaks up into x and x minus 3 squared. Hold on. Okay, so then back to it, because this would be x minus 3 times x minus 3, so it's x minus 3 squared. So x equals 0, our first part, has a multiplicity of 1, because it only happens once. Where x minus 3 happens twice, so that means x is equal to 3, but the multiplicity is twice, right? Because it's happening twice. So then I'm going to show you how it affects a graph. I'm going to plug that same equation in. So minus 6x squared plus 9x. Okay, so when I graph it, so there's a 0 here and a 0 here. I should find the maximum. Is at 1, 4. All right, so here's my graph. When the multiplicity is odd, so there was one multiplicity here at 0, it goes through that 0, so it crosses the graph. When it's even, so notice the multiplicity here was 2. So when it's x equals 3, since that was a multiplicity of 2, it bounces at that 0. So then if I look at this example, notice they broke it up for us. It's already factored. So the 0, let's start with x plus 7 equals 0. So our 0 would be negative 7. It's squared, so our multiplicity is 2, which is even, so it should bounce. Let's do the next one. 2x plus 1 equals 0, which if you undo that, x equals negative 1/2. It has a multiplicity of 1, so that means it crosses. The last one is x minus 4 equals 0, so that would be positive 4. It has a multiplicity of 3, which is odd, so that one also crosses. All right, so looking at the exponents tells us our multiplicity, and if it's even, it bounces. If it's odd, it crosses.